Now students, let us see some more interesting sums in exercise 6.2. So here, the 17th term of an AP exceeds its 10th term by 7. Find common difference. So here, given that in an AP 17 term, that is A17 is equal to its 10th term by exceeds its 10th term by 17, that is it is more than that of the 10th one, that is we should add 7 to that of 10th term, then we get 17th term. So here to write A17, 17th term and 18th term, we have to apply AN formula. So what is AN formula? AN is equal to A plus N minus 1 into D. Now here A17 is A plus 17 minus 1 into D. That is A17 is equal to A plus 16D. Now similarly A10 is simply you can write A plus 9D. So from 1 we can write A plus 16D is equal to A plus 9D plus 7. Now take that A plus 9D plus 7 on left side. Then A plus 16D minus A minus 9D minus 7 is equal to 0. Now here A minus A gets cancelled. 16D minus 7D. 7D minus 7 is equal to 0. Then 7D is equal to 7. Therefore, D is equal to, we can write 7 by 7. And hence, D is equal to 1. So by this, we can write down. We can get the common difference. Okay. Now the next one. This is also very interesting and most important. Listen carefully. The next one here. How many 3-digit numbers are divisible by 7? Now simply here we have to get 3-digit numbers which are divisible by 7. Okay, so for that we have to write first of all the first 3-digit number divisible by 7. For that we need first of all the highest number or biggest number in 2-digit. What is it? Biggest number in 2-digit. So we can say it is immediately 99. Then the smallest one 3-digit number, the smallest 3-digit number, that is simply you can say 100. So the 3 digits are start with 100. Now to get the multiple of 7 or 3-digit number which is divisible by 7, we have to check. Take for example 105. Okay, divided by 7. 7 1s are 7. 10 minus 7, 3. Balance 5. And remaining 7 5s are 35. So it is 105 is the first 3-digit number. Otherwise, you can do like that also. Then 98, before 99 we got 98. 98 is also a multiple of 7. That is 98 is simply divisible by the 7. That is 98 14s are, or 98 1s are, 7 1s are 7, 28, 7 4s are 28. So 7 14s are 98. So by that way we can say the last 2-digit number which is divisible by the 7 is 98. Then add 7 to this one. Then add 7 to this one. So simply we get what? 105. Okay. So by that way also we can find the first 3-digit number which is divisible by the 105. So in solution, first 3-digit number divisible by 7 is simply you can write 105. So we can write the list of that numbers. List of those numbers. Simply starting with 105. Immediately you can write plus 7. Why? Because actually it is a table of 7. So 105 plus 7 you can get simply 112, and 112 plus 7 simply you get 119. Up to so on, we have to write down here the last 3-digit number which is divisible by the 7. For that also we need to get here the biggest number in 3-digit. Biggest number in 3-digit. What it is? Simply you can take 999. Okay. So is it divisible by 7? No. So that's why you have to divide it by 7. First of all, 7 1s are 7. 9 minus 7, 2. 9. 7 4s are 28. So remaining 19. 7 2s are 14. So what do you get remainder? 5. So if we are getting excess, that means here 5 is the remainder. So if that 5 is subtracted from this 990, then we get automatically the divisor of the 7. That is the last divisor of 7 which is in 3-digit. So that means here the last divisor is simply you can take here I am writing 999 minus 5. That is here we got remainders 5. That's why you got the last as 994. Okay. Now here we got the last digit 994 and the first last number 994, that is AN, and the first number A1 is A. So above list is compulsory in the AP. So that's why we can take A1 is equal to A is equal to 105, and the common difference simply you can write 112 minus 105 is 7, and then here AN is 994. Okay, by substitute A value and D value in the formula of AN, then we get easily the number of terms which are divisible by the 7. So AN formula is what? A plus n minus 1 into D is equal to 994. So here A value is 105 plus n minus 1 into D is here 7 is equal to 994. Take this 105 on right side. So n minus 1 into 7 is equal to 994 minus 105. So by taking subtraction we get 14 minus 5 9, 128 balance. Here also 8. That is n minus 1 into 7 is equal to, we got 889. Now n minus 1 is equal to 889 by 7. Now cancel it by 7 table. 7 1 the 7, remaining 18, 7 2 the, and remaining 49, 7 7 the. So n minus 1 is equal to 127. So hence n minus 1 is equal to 127. Then n is equal to 127 plus 1, that is equal to 128. So the number of 3-digit numbers which are divisible by 7 are 128. So this is very important, very important, this sum. So practice well. Okay, and next, now let us take one more like this sum. How many multiples of 4 lie between 10 and 250? So let us write here solution. So the multiples of 4 in between 10 and 250. So first multiple of 4 after 10 is simply you can say 12. So we have to write the list of multiples of 4 in between 10 and 250 are, simply you can start with 12 and then immediately you can write 16 and then 20 up to so on. Again we have here last 250. So to get the multiple of 4, already we did in 7 table. So here we have to check up 4 tables. So 4 6 are 24, 5 minus 4 1, 10 balance. So 4 2s are 8. Again we got here 2 as a remainder. If you subtract 2 from the 250, see here children, very logical and simple one. So 250 minus 2, what do you get? Simply 248. So we can check up whether it is 248 divisible or not by 4. Okay. Now 4 6 are 24, 0, then layer balance 8, 4 2s are 8. Or otherwise we can say by the divisibility rule by saying the last 2 digits. We know the divisibility rule of 4. The last 2 digits are divisible by 4, then the given number must be divisible by 4. So that's why 248 is the last number which is multiple of 4. Okay, so we got a list here. Now here also we have to get the number of these set of numbers. Okay, now to get that one, again we need the AN formula. So here A value is 12 and D, of course, it is 16 minus 12, simply get 4, and then AN we have 248. It is last term of this list. Now AN formula, what is that? A plus n minus 1 into D is equal to 248. Now substitute A is equal to 12 plus n minus 1 into D value 4 into 4 is equal to 248. Now take this 12 on right side. On simple simplification we get n minus 1 into 4 equal to 248 minus 12. So by that way we can write n minus 1 into 4 is equal to 236. And now the way we can write n minus 1 is equal to 236 by 4. Simply transpose 4 to that side. So we get it on the denominator, that is it divides 236. So now 4 ones are 4 5s are balance 36, 4 9s are. So n minus 1 is equal to 59, then n is equal to 59 plus 1, so simply we get 60. So the 60 multiples are there in between, the multiples of 4 in between 10 and 250. Okay, there are 60 multiples of 4 in between 10 and 250. So this is also very important. Practice. And then next, most important, one more sum, very interesting. For what value of n are the nth terms of two APs 63, 65, 67 up to so on, and 3, 10, 17 up to so on equal. That is, for what value of n these two terms are, and the terms are equal up to these two APs. So here first of all, first write the first given AP. What is the first AP here? First arithmetic progression 63, 65, 67 up to so on. So first find here nth term of this one. So that only they are asking. So to get nth term, again we need A and common difference, that is D is equal to A2 minus A1. Then by saying also we can say, but to the process, 65 minus 63, that is 2. Now what is AN? AN is equal to A plus n minus 1 into D. So here A value 63 plus n minus 1 into D, 2. Now simplify it. 63 plus 2 into 1, 2 into n to n minus 2. 63 minus 2, 61. 61 plus 2n. So this is equation 1. And in similar way, second AP. What is second AP? What we have? 3, 10, 17 up to so on. Okay. Now here again, to get AN we need A and D. A value 3, D value A2 minus A1, 10 minus 3, that is simply 7. Now AN is equal to, what is the formula? Once again, A plus n minus 1 into D. Now write that, substitute that values, A value 3 plus n minus 1 into 7. Now 3 plus multiply this 7, 7n minus 1 into 7 minus 7. 7n, 3 minus 7 minus 4. So this is equation 2. Okay, but it has given that these two nth terms are equal. Okay, so then only we get that n value. Okay, now here given that nth terms are equal, so that we can write from 1 and 2. So what we have, the first nth term is here 61 plus 2n is equal to the second nth term is 7n minus 4. Okay, now take the 7n minus 4 on left side, we get 61 plus 2n minus 7n plus 4 equal to 0. Now 2n minus 7n minus 5n plus 61 plus 4, 65 is equal to 0. So minus 5n is equal to, take the 65 on right side, we get minus 65. N is equal to minus 65 by minus 5. 5 gets cancelled, we get n is equal to simply 13. Okay, that means the 13th terms of the both the APs are equal. That is 13th term of the first AP and 13th term of the second AP is equal. Okay, next That is 13th term of the first AP is equal to the 13th term of the second AP. Now let us see one more important sum. Find the 20th term from the end of the AP 3, 8, 13 up to so on 253. So here we have two methods. First let us see the first method. So here first given AP. What is the given AP? 3, 8, 13 to so on 253. First you find the number of terms in this set of AP. That is set of the numbers. So here to get that one we need again AN. Okay. Now the first term A is 3. D common difference A2 minus A1. That is 8 minus 3. Simply 5. Now AN is here 253. AN is 253. Apply the formula. A plus n minus 1 into d equal to 253. Substitute 3 plus n minus 1 into 5 is equal to 253. Now then n minus 1 into 5 is equal to 253 minus 3. N minus 1 into 5 is equal to 250. Then n minus 1 is equal to 250 by 5. By cancellation we get simply 50. So n minus 1 is equal to 50. N is equal to 50 plus 1. N is equal to what? 51. That means we have here 51 terms in this series. So to get 28th term from the last, we have a formula for that. What is the formula? The pth term of the AP from the last is n minus p plus 1 term from the beginning. That means here we have n value is how much? 51. P value is how much? 20. That is asking term 20. Now from the beginning we can get the number of term from the beginning. That is from the starting. From the beginning means from the 3. From the beginning, from the 3. From the first number 3. From the beginning we can write simply the number we are getting. So 51 minus 20 plus 1. So 51 minus 20, 31. 31 plus 1. Simply you get what? 32. That is A32 is equal to the 20th term from the last. That is A32 is the from the beginning and A20 is the from the last. So A32 formula. So to get A32 we can apply simply AN formula. A plus 32 minus 1 into D. So here A value is 3. 32 minus 1, 31. D value is simply what we have D value? 5. Now 3 plus 155. Okay, so 31 is 155. Now 153 plus 155 plus 3 is simply 158. Okay, this is a one method. Okay, now let us see the second method also. So simply simple method, that one. The second method. So here again I am writing the given AP. what is given AP? 3, 8, 13 up to so on 253. Okay, so here the last term the term that is the 20th term from the last. Here we can write a formula L minus n minus 1 into d. Okay, so here, or you can write here the nth term from the last, that is Tn is equal to L minus n minus 1 into d. So we need here T20. T20 is equal to L minus here n is 20 minus 1 into d. So L minus 20 minus 1 is 19. But whereas what is L here? L is 253, last term 253. And what is D? D is simply 8 minus 3, simply 5. So by substituting we can write 253 minus 19 into 5. So 253 minus 95. So what do we get here? By subtraction of this we can get easily 13 minus 5, 8. Here we got 14 balance, 14 minus 9, 5 balance 1. So here also we got 158. Okay children, so in that way we can get the simplest. These two are another formulas, so keep concentrate on these formulas, the nth term from the last. Okay, so I will write here once again the formulas, keep a note on that one. So in this first method formula is, what is the first method formula? Here pth term of the AP from the last is equal to n minus p plus 1th term from the beginning. Okay, and the second method formula, simply the nth term from last of the given AP. That is simply you can write here, and taking the nth term as Tn here. Tn is equal to L. L is the last term of the given AP. So n minus 1 is the term number of the asking term number, and D is the common difference. Okay, so L is here last term of given AP, and N is required number of a term. So by applying these two simple formulas, you can easily get these type of sums. Okay, and the next, our daily life. Subbarao started work in 1995 at a monthly salary of rupees 5,000 and received an increment 200 each year. Okay, in which year did his salary reach rupees 7,000. Okay, already we discussed same type of sum in the example of getting nth term. Or you remember this? There we are taking Usha's salary 8,000 rupees per year and 500 is her monthly increment. So same in that way, he has to borrow. Okay, he got a job in 1995 and her monthly salary in that year is 5,000 and annual increment is 200. So here given monthly salary of Subbarao in starting year is equal to 5,000. That is, we can take it as a term A1, that is simply A. And that annual increment is every year, every company, you know already, every year gradually they are increased that amount, salary amount. So here his increment is 200 rupees, 200. So for the next year, okay, we have to write that 2 to 3 terms now to get that series or to get the list. So that's why I'm writing that for the second year salary. Okay, how much secondary salary for every month? So that is 5,000 plus 200. In the second year he got 5,200. Okay, that means in 1996. In 1995 he got 5,000. He got that job in the 1995. So this one is the 1996. So anyhow, but we need to get only these terms. Okay, so now similarly you can write the list. What is the list here? Similarly you can write first third year. Similarly third year salary. How much is that? You can say directly 5,200 plus 200. Why? Because here 5,000 is the first term, 200 is a fixed number or the common difference. To get the successive numbers, we should add the 200 to the previous number. Already we did like this example. Okay, so now we'll write the list of salaries. Okay, what are the numbers? 5,000, 5,200, 5,400 up to so on. They give the last one, that is 7,000. They give what? 7,000. So here till we have to write 7,000. Okay, so that means he got 7,000 salary for a particular year. So we have to find that year number. Okay, now to get that one again we need the AN formula. So here A is equal to what? 5,000 D A2 minus A1. Simply get what? 5,200 minus 5,000, simply 200, or you can write directly 200 also. Now here AN is what? 7,000. Okay, so AN formula A plus N minus 1 into D is equal to 7,000. Now substitute A value and D value. Okay, so by substituting them we can write 5,000 plus N minus 1 into 200 is equal to 7,000. Now here take this 5,000 on left side, we get simply N minus 1 into 200 is equal to 7,000 minus 5,000. N minus 1 into 200 is equal to 2,000. Then next, N minus 1 is equal to 2,000 by 200. 2 zeros to this gets cancelled. N minus 200 to 10. So he got N is equal to 11. So in the 11th year he got the 11th year, he has to his salary reach reach 7,000. That means we should add 995 plus 11. That is how much? 2006 year. Okay. So like this, you have to do this type of important sum. Now let us see another sums in next videos.